Hello, everyone. Okay, I say everyone like there's going to be a lot of people. There's probably like 3 people going to watch this, okay, including myself. So. Anyways, we're going to do a really quick lighting maps. It's going to be 6 pages. That's it. We're going to page 160, and that's all. So let's just get started, get right into it here. In the previous tutorial, we discussed the possibility of each object having a unique material that reacts differently to light. This is great for giving each object a unique look in comparison with other objects in a lighted scene, but still doesn't offer too much flexibility on the visual output of an object. Really? In the previous tutorial, why do we have to talk about the past so much? I swear, it's just, really? We defined a material for an entire object as a whole, but objects in the real world usually do not consist of a single material, but consist of several materials. Think of a car. Its exterior consists of a shiny fabric. It has windows that partly reflect the surrounding environment. Its tires are all but shiny, so they don't have specular highlights, and it has rims that are super shiny if you actually washed your car all right. The car also has diffuse and ambient colors that are not the same for the entire object. A car displays many different ambient diffuse colors. All by all, such an object has different material properties for each of its different parts. So the materials system in the previous tutorial isn't sufficient for all but the simplest models. So we need to extend the previous system by introducing diffuse and specular maps. These allow us to influence the diffuse and indirectly the ambient components, since they're almost always the same anyways, and the specular component of an object with much more precision. Okay. So what we want is some way to set the diffuse color of an object for each individual fragment. Really? Some sort of system where we can retrieve a color value based on the fragment's position on the object. This should probably all sound extremely familiar, and to be honest, we've been using such a system for a while now. This sounds a lot like textures we've extensively discussed in one of the earlier tutorials, and it basically is just that, a texture. We're just using a different name for the same underlying principle, using an image wrapped around an object that we can index for unique color values per fragment. In lighted scenes, this is usually called a diffuse map. This is generally how 3D artists call them. Excuse me, since a texture image represents all of the object's diffuse colors. To demonstrate diffuse maps, we're going to use the following image of a wooden container with a steel border. Using a diffuse map in shaders is exactly the same as with the texture tutorials. This time, however, we store the texture as a sampler 2D inside the material structure. Excuse me. We replace the earlier defined vector 3 diffuse color vector with the diffuse map. Keep in mind, whoops, I'll be right back. Okay, so it says keep in mind that sampler 2D is a so-called opaque type, which means we can't instantiate these types, but only define them as uniforms. Sampler 2D, If we would instantiate this structure other than as a uniform, like a function parameter, GLSL could throw strange errors. The same thus applies to any structure holding such opaque types. We also remove the ambient material color vector, since the ambient color is in almost all cases equal to the diffuse color, so there's no need to store it separately. Sampler 2D diffuse, vector 3 specular, float shininess, material, texture chords. So what is our material right now? Let's go back to here. Where are we at? 2D displays. what is our thing right now? Material, ambient, diffuse, specular, shininess. Specular and shininess are the same. We're changing diffuse to be a sampler 2D diffuse. We also remove the ambient material colors since the ambient color is almost all cases equal to diffuse colors, so need to store it separately. Really? Okay. If you're a bit stubborn and still want to set ambient colors to a different value other than the diffuse value, you can keep the ambient vector 3, but then the ambient colors would still remain the same for the entire object. To get different ambient values for each fragment, you'd have to use another texture for ambient values alone. It's kind of what we're doing for the diffuse. Okay, note that we're going to need texture coordinates again in the fragment shader, so we declared an extra input variable. Then we simply sample from the texture to retrieve the fragment's diffuse color value. Then we simply sample from the texture to retrieve the fragment's diffuse color value. Diffuse equals light diffuse times diff times vector 3 texture material diffuse texture coordinates. Also, don't forget to set the ambient material's color equal to diffuse material's color as well. Ambient equals light ambient times texture material diffuse texture coordinates. And that's all it takes to use a diffuse map. As you can see, it's nothing new, but it does provide a dramatic increase in visual quality. To get it working, we do need to update the vertex data with texture coordinates, transfer them as vertex attributes to the fragment shader, load the texture, and bind the texture to the appropriate texture unit. The updated vertex data can be found here. The vertex data now includes vertex positions, normal vectors, texture coordinates for each of the cube's vertices. Let's update the vertex shader to accept texture coordinates as a vertex attribute and forward them to the fragment shader. Oh, is that all? Okay. Well, I thought this was going to be quick, but I mean, I can do this. It's just going to take a little while. Be sure to update the vertex attribute pointers of both VAOs to match any vertex data and load the container image as a texture. Before drawing the container, we want to assign the preferred texture unit to material diffuse and uniform sampler, bind the container texture to its texture unit, blah, blah, blah. Now, using a diffuse map, we get an enormous boost in detail again. This time with added lighting, the container really starts to shine. Quite literally, your container now probably looks something like this. Well, I guess we can try this. Actually, I'm just going to look at it. Make sure that I've got everything. What do we need to add? Oh, the vertices. There you go. And that's got the normals and the texture. Positions, normals, texture coordinates. So let's put that in. Come on. Okay. There we go. So the vertices are in there. First, set the containers VAO and VBO. Now does that change? VBO, container, VAO. I think a lot of stuff is going to change, so shoot. Okay, we can do that. Oh, container, oh wait, container? Why does this? Does it? How did that get in there? I don't remember that. It's okay. It's alright, I'm too old to remember stuff sometimes. Okay, so that looks good then. VBO, container, VAO, VBO. And it goes through vertices, static draw. Here's the vertex area trib pointers. We need to make sure those, oh, we don't want to do that, just here. Okay, because we need 3 of them now instead of just 2. And plus each one, I think this number will change. Let's just take a look. Yeah. This just changes to 8 and 8. And then the last one, so we can actually just get rid of these here. 0, 1, all that, boom. Then we just take that out, put that in there. Now we're good. So that will give you the position, the normal, and the texture coordinates. So we have the position, normal, and texture coordinates. Okay, great, great. That's great. You know, it's great. Okay, and the light VAO, huh? Would you care for your light VAO, sir? Okay, so 0, 3, 8. Float, false, 8 right there. Why is that 8? Light VAO? Light VAO. Bind buffer VB. Oh, so it's using the same vertex buffer. So the vertex buffer, see the vertices. So it's using the same vertices for the light. Okay, all right. So that's why that's that. And it's just, okay. All right, we're good. Moving on, moving on. Okay, so diffuse map. Oh, this is new. This is new. Diffuse Map Container 2.png. Should I get that from here? Hold on. The following image. That's a PNG. Can I save it as a PNG? Let's go to 2D displays. Awesome face PNG. Okay, well it's letting me save it as a PNG, so that's good. 2D displays, container 2.png. Good, good, good. Whoa, excuse me, I got something going on. You might be catching what's going around. Great, great, great. Okay, so texture units. Okay, so do we have any of this in here? No. So actually all of that needs to be added in there. It doesn't do this, lighting shader.use. Don't you do that in there? Lighting shader.use. No, it's used later right there. Okay. Okay, so now we're going to use the diffuse map, generate textures, a diffuse map with height, share image, so it's loading the image. Diffuse map GL texture 2D. Okay. And then it's just gonna put it in the texture. Soil free image data, and then it does all this stuff, and then it binds the texture, takes it away, and then okay, so the texture is right here in diffuse map, right? Yeah. Okay, lighting shader use, get uniform location, material diffuse. I've also got this down here. So material diffuse, is it also used down here? No, so they took it out down here. So we still have that and that and that, and then we come down here, lighting shader use. So it uses it right there, then it uses it here again, and it does all this fun stuff here. Most of this part is the same. Like if you look at the lamp shader use, lamp shader use, model loc, view loc, projection loc. Yeah, that's getting the uniform variable from there, lamp shader. And then it does viewpointer, view, projection. And I'm looking right here, matrices, model, light position. So that doesn't change. None of that changes. Back and forth, folks, back and forth. You are now under my command. No. Kidding. Okay. So, lighting shader use. Lighting shader use. Hello, way up here. Okay. And then it does what? I am such a freak. Okay, light position, location, view position, location, and all this. Let's just copy this. I don't want to look through and make sure it's all correct. I just want to copy it. Lamp shader use. Okay, so everything from there down to lamp shader use. So from light shader use, we'll just get rid of all this other stuff that I just had to save. I just had to save it. Down to there. Okay. Paste it in. Hit enter. Okay, everything seems to agree with the compiler, so that's good. And then everything else is the same. We know it is. Down here, terminate, callback, do movement, first mouse. Okay, that's easy stuff. Compile. Whoa. Excuse me, no errors. Okay. And it doesn't work. Why didn't it work? I like how it just shocks me still. It still shocks me. It doesn't work. Alright. Not shocked. Gotta figure out why it doesn't work. I suppose. So where is... What else? What else am I missing? I have all that copied. I have all that. Is there something different about this stuff? Did it copy it and put in spaces or anything weird like that? Oh, actually, let's look at it again, because no, there's no errors from the it's not showing the texture, which is a little weird. Oh wait, we didn't update the we didn't update, that's why, because we didn't update the lighting maps, right? Diffuse maps, following image. Okay, because we didn't update the shader. It's kind of important if you're working with shaders. You need to kind of do that. So sampler 2D diffuse, we need to change that. And then take out ambient, don't need it. Shininess is still there. In vector 2 text chords, because we need that. Okay, save it. This is the fragment shader. The updated vertex data can be found here. What about the shader? So I can just copy it. Full source code of the application here. Oh man. Oh good. Here. Vertex fragment shader. Where's the control? Here. There. Okay, vertex shader. Oh yeah, and we gotta update the vertex shader too. For the hold on. So we need to, let me just type it out so I'll remember it better. Layout location equals 2 in vector 2 text chords. Great. Okay. Still need those, but we need this out vector 3 normal frag position, out vector 2 text chords. Okay. Position equals that. We're good. Model normal equals normal. Okay, right here. So normal equals what? What? So matrix 3 by 3. What? Transpose. Transpose. Inverse. Model. What are we doing? What in the world? Text chords equal little t text chords right there. Okay, save that. So the vertex shader is good. Fragment shader looks quite long and involved. Let's just go like this. Copy it. There. Save it. Close it. Did I jump the gun? No. Oh, nice. This is nice. So let's go down and kind of there. That is so cool. Of course, didn't we know that we could do this before? I think we knew we could do that before. Are we done? Did we finish, or did we just jump far ahead and finished everything? Specular maps, diffuse map. What did we do? So where did I stop and like start copying, pasting? Let's update the vertex shader to accept texture coordinates as a vertex attribute and forward them to the fragment shader. So this is where they go into the vertex shader, and this is where they go out, and this is how it does that, because the out is equal to the in. Okay. Be sure to update the vertex attribute pointers of both VAOs to match the new vertex data and load the container image as a texture, which we did that. We just copied and pasted that. Before drawing the container, we want to assign the preferred texture unit to material.diffuse uniform sampler and bind the container texture to this texture unit. So here's the uniform, gets the material diffuse, active texture, bind texture, diffuse map. Now so what does that do? We want to assign the preferred texture unit, okay, to the material.diffuse uniform sampler. Okay. Texture unit uniform sampler. Okay. Now using a diffuse map, we get an enormous boost in detail again, and this time with added lighting, the container really starts to shine, quite literally. Your container now probably looks something like this. You can find the full source code of the application here. You probably notice that the specular highlight looks a bit off since our object is a container that mostly consists of wood, and we know that wood doesn't give much specular highlights. We can fix this by setting the specular material object to vector 3, 0, but that would mean that the steel borders of the container would stop showing specular highlights as well. We also know that steel should show some specular highlights. Again, we'd like to control what parts of the object should show a specular highlight with varying intensity. This is a problem that looks really familiar to the diffuse maps discussion. Coincidence? I think not. We can also use a texture map just for specular highlights. This means we need to generate a black and white or colors if you feel like a texture that defines the specular intensities of each part of the object. An example of a specular map is the following image. Specular map, following image. Okay, specular, container, specular, PNG. Okay, ready? 2D displays, we're putting it in there. That's cool. Okay. Wow. Specular map is the following image. Okay. The intensity of a specular highlight is retrieved by the brightness of each pixel in the image. Each pixel of the specular map can be displayed as a color vector where black represents the color vector 0 and gray the color vector is 0.5, for example. In the fragment shader, we then sample the corresponding color value and multiply this value with the lights. Oh, really? The more white a pixel thus is, the higher the result of the multiplication, and thus the brighter the specular component of an object becomes. Because the container mostly consists of wood, and wood as a material should have no specular highlights, the entire wooden section of the diffuse texture was converted to black. Black sections do not have any specular highlight. The steel board of the container has varying specular intensities, with the steel itself being relatively susceptible to specular highlights, while the cracks are not. Technically, wood also has specular highlights, although with a much lower shininess value, more light scattering, and less impact. But for learning purposes, we can just pretend wood doesn't have any reaction to specular light. Using tools like Photoshop or GIMP, it is relatively easy to transform a diffuse texture to a specular image like this by cutting out some parts, transforming it to black and white, and increasing the brightness contrast. Really? That would be something I would be interested in learning. That would be something that I would be interested in doing. Okay, well, when we come back to this chapter, because we're going to revisit this, because I mean, obviously I'm skimming through this, and I'm just getting familiar with it so that I can understand it eventually. Although it seems pretty easy. I'll come back and I'll see that. I want to remember to do that. Okay, anyway, sampling specular maps. Okay, a specular map is just like any other texture, so the code is similar to the diffuse map code. Make sure to properly load the image and generate a texture object. Since we're using another texture sampler in the same fragment shader, we have to use a different texture unit. See textures for the specular map, so let's bind it to the appropriate texture unit before rendering. Uniform, material, specular, texture. This time they choose GL texture 1. Okay, bind texture 2D specular map. So it sets the active texture for this, and then it binds this to specular map. Okay, got it? Got it? Good. Then update the material properties of the fragment shader to accept its sampler 2D as its specular component instead of a vector 3. Material, sampler 2D float. Oh, dude, that just clicked with me. That's what we did with diffuse. Now we're doing it with specular. Okay, why did it take until now for that to click? If you're using a texture and you're going to add the texture into the calculation, interesting. Just use a sampler 2D thing. Okay, that's cool. And lastly, we want to sample the specular map to retrieve the fragment's corresponding specular intensity. Ambient equals light, ambient texture, material, diffuse texture coordinates, diffuse equals light, diffuse material, texture coordinates, specular equals light, specular, texture, material, specular, texture coordinates, ambient, diffuse, specular 1. By using a specular map, we can specify with enormous detail what parts of an object actually have shiny properties, and we can even set their corresponding intensity. Specular maps thus give us an added layer of control on top of the diffuse map. If you don't want to be too mainstream, you can also use actual colors in the specular map to not only set the specular intensity of each fragment, but also the color of the specular highlight. Oh, cool. That's cool stuff. Realistically, however, the color of the specular highlight is mostly completely determined by the light source itself, so it wouldn't generate realistic visuals. That's why the images use black and white. We only care about the intensity. If you would now run the application, you can clearly see that the container's material now closer resembles that of an actual wooden container with steel frames. You can find the full source code of the application here and compare your shaders with there and there. Okay, so I did compare my shaders, but I didn't get the full source of the application and compare because he decides to load, see right here, specular map. So to load textures, it goes through that, and then we just want to include this. Okay. So right here, and we're not going to unbind it, we'll do unbinding at the end. See, it already does that, so we don't need that. Specular map, so right up here, probably. Yeah, they added it up there. Okay, and generate the texture, you need to put that line in there too. What are you doing? What are you doing? Save it. Good. Container 2, specular PNG. I don't know if this will work yet. No. Where's the... Is that working yet? Hold on, where's the thing? Go down. There. Is it brighter on the steel? Hold on, so there's... What else did we have to do? Oh, and we have to add that too. Get uniform location lighting shader program material specular 1. Goes right there. Boom. Hold on, we gotta figure out what else. Okay, so this here, lighting, camera, model, shininess. Oh, right here, bind specular map. So it's okay, that's cool. That's really cool. I'm not sure that'll work yet, but let's see. Yep. it is actually applying it now. You can see how it's only specularly highlighting the steel. That's cool. That is really cool. I can't believe that that does that. That's really cool. Huh. Huh. Okay. Yes. So that's probably the end of it. Let's just finish up the end of it here. You can find the full source code here, blah, blah, blah. Using diffuse and specular maps, we can really add an enormous amount of detail into relatively simple objects. We can even add more detail into the objects using other texture maps, like normal, bumped maps, and or reflection maps. But that is something we'll reserve for later tutorials. Now I'm excited. Show your container to all your friends and family and be content with the fact that our container can one day become even prettier than it is today. Than it already is. Okay, fool around with light source ambient, try and invert the colors created. Okay, so we'll do this later. And then we're ready for light casters later. Okay, eyes of a robot, strips on a container. Okay, thank you all for tuning in. That was 31 minutes. All right.